All right, so we are going to go over the second part of the data input, data output lecture. So we should have done some of the lab so far. So we are going to read in one of the or one of the packages that we'll be using for this course called dplyr. So there are ways to change the column names or row names of a data set. Particularly, most data sets only have column names, but there are ways to change the row names as well. But we're not really going to touch on that because pretty much any information about a data set should be in a column of that data set and not a attribute like a row name. So one of the functions that allows us to rename columns is the rename function by dplyr. So we are going to load up the dplyr package by using library dplyr. You could put quotes around dplyr, but that is loading it into memory so R can actually access the functions from that package. One of the functions from that package is the rename function. So what we're going to do for dplyr, one of the biggest things we will hammer home in other lectures, the first argument to every dplyr function is the data set. So here we are going to say dat equals rename dat. So we're reassigning dat. So we're going to take the dat data set, put it in the rename function, and now the syntax for what we're doing in rename, new equals old variable. So new variable name equals old variable name. The old variable name was capital YEAR for year, and we want to make that lowercase. So this whole function right here will output an entire data set, and then we're reassigning that complete output to dat. So many times when we're using dplyr functions, which we will talk about more in data manipulation and summarization, is that people will run rename dat year equals year, and what that will do is it'll print out a data set with the first column now will be lowercase, but if you don't reassign it, remember, none of that will stick, and you will just have printed everything out, but nothing will have changed on the data set itself until you do this reassignment. So you can use the column names function or the names function, and here we're saying names dat just to show that the column names of the data set are in fact, the first one is in fact lowercase year. So you could also say row names. That'll give you the row names of this data set, but it has no row names, so it's just going to give you 1 to the number of records. Again, you could use n row, n column with the number of columns, number of rows, but column names, row names of a data set will give you the column or row names respectively. But if you just use the names function, which is also useful for vectors, by default on a data set, a data frame, a tibble, it'll give you the column names. So once you have gotten a data set in, you've done some manipulations, maybe make a table, maybe you want to put an output right somewhere. You want to write a CSV somewhere or write a text file, things like that. It's very nice to be able to read them in. It's really nice to be able to write them out into a variety of formats. I will say the majority of the time that I do output specific data set types that's not in a report like an R Markdown document, I use CSV files or comma separated files. So again, read R, although its name obviously is about reading, also has a bunch of write functions. So like there is a read underscore delim, there is a write underscore delim. So the first argument is the data set, the second argument is the path, and in this case you could say delimiters. What do you want to put where there are missing values? Do you want to append to this file so you can actually write out a whole chunk of things, and then you can actually append things on top of it. And then if you append this, so this is what these arguments mean. Append equals false. And again, we've touched on logicals very briefly, but again, false is all capitals. So that is saying I don't want to append. And what this is saying is the default argument for column names is the opposite of append, so not append. So by default, this is false, which means this is true, which by default, you don't append, but you do give column names. Again, if you're stacking data sets on top of each other, it's not a good idea to put the column names over and over again, because if you're not careful, somebody will think that is data, where it's actually just an attribute of the data, not the data itself. So by default, if you append something to it, it won't put the column names in there. But there is a way, if you set this to true and this is true, you can do some funky things that you probably don't want to, where you can append the data to that path if it already previously exists, and you will re-put the column names in there. So again, X is the data frame or matrix or tibble that you want to write. Path is the file name where you want it to be written. It could be an absolute path or a relative path. Again, we definitely argue that relative paths are better in many instances. The delimiter, you could say comma, right, to make it a CSV. Again, \T for tab to make a tab delimiter file, but really most times I use the write_CSV function. Again, there are other functions in R that come in the base package, right? So the write.table, write.csv, for the most part, we discourage you from using them because they have defaults, which sometimes can have a little bit of a gotcha if you don't know kind of the ins and outs of them. Usually they're also slower. And for the most part, the readr functions work better. So, but for the most part, I usually make the dataset CSV because a lot of people want to open them in Excel. So here we will rename the data again, just to show you again how the function works. We're reassigning the dataset year now has a capital Y, and now we say write_CSV. We put this dataset and we say the path equals the CSV output. Again, in functions, in arguments, you can name them. So this is a path is a named argument in this function, or you can put them by position. So by default, the first argument in write_CSV dat is the data set. It knows to assign X to that. Now I will say, if you say X equals something over here, it'll say X is this, path is this, and then it'll assign this to be the third thing in order, which is usually not what you want to do. So just to be very explicit in the future, I would say write_CSV, X equals that, path equals this, just to make sure I've specified them the way I exactly want them. And if you specify them like that, if you say X equals that, path equals this, it doesn't matter the order you put them in, R knows which one is assigned to which. So I would say go to the lab and work on the part of the lab that pertains to renaming. I'm going to move on with the lecture, but you can pause here and stop. So we've talked about this at length about reading in data sets. R can read in a whole bunch of things. We really only showed you CSVs and tab delimited files, but there are some other options. Obviously, you can read in almost any type of thing with the read_ functions that are kind of flat files, as they're called, or plain text files. You can save an Excel sheet as a CSV file and read it in using read_CSV. But you can read data directly from an Excel spreadsheet using some of these add-on packages. OpenXLSX and XLSX were really good packages, but I believe the one we would highly recommend is ReadXL. It's from RStudio. I've used it extensively. It's got a good, nice functional interface. It really has some clean functions. The arguments are intuitive. So I would say that would be the one I would use if you want to read directly from an Excel file. So there are other packages to read from, like Google Sheets and databases and things like that we're not going to cover as much, but if you have questions about that, don't hesitate to ask. So for single worksheets, again, I would probably write it out as a CSV, but just understand sometimes when you go to Excel, the data can actually get formatted a little funky. So certain things, it tries to be smart and you say 05-04, sometimes it tries to infer those things to be dates. So just always be aware if you're passing through Excel, there can be some issues. So again, if it's multiple data sets or multiple worksheets, I almost extensively use the ReadXL package. Now, reading and writing other types of data formats, I would say the Haven package is amazing, right? It can read SAS, it can read SPSS, it can read Stata, it can read other data formats out there. It can write those data formats out there. We just talked about the ReadXL package, which has the read_XL function. The readr package we talked about throughout this entire course and entire lecture, and it's very fast for large data sets. SAS7BDAT reads SAS7BDAT files, which is a SAS extension. Foreign package exists out there, but it can read all the formats as Haven, but it's really, it's been around longer, but more or less it's not been maintained. The people that wrote it said, hey, use Haven for the most part. Some of these are now available from RStudio drop-down lists, so SAS, Stata, SPSS. There is also a function called fread in the data.table package, which is really, really fast at reading CSV files. But unless you need like extensively large data, most likely I will use the readr package. So just like there's SAS files like SAS7BDATs and .sas files for SPSS or .dtas for Stata, there is an R data set or R data object kind of format. If you want to save one object, and that object can be a list of things, we will talk about lists later. They're essentially amalgamations of a whole different types of things. But many times, for example, if you want to save a data set, you want to save a model, you want to save a table, something like that, that you can use write_RDS. So the nice thing about the readr package as well is it kind of harmonizes all the syntax. So it's read_write_ and then the data type. So again, like write_CSV, the first argument is the thing you want to write out and then the path. So our data sets or our data serialized objects, that's kind of what they are in this capacity, have the extension RDS. And usually I always put them in lowercase, but sometimes I would just do that just for here on out if you're starting out in R. But this saves one object, you write it to disk. You can also compress these things, but they're very fast for reading and writing in R. So if you don't want to save a CSV file that can get really, really, really big, you can save this thing in a compressed format and read it in very fast in R. Now I want to show you this. So when you read in an RDS file, again, you're going to use the read_ function from the readr package, and you give it the path. And this was the data set we just pulled in. I called this DAT2. So again, on here, I wrote DAT out. Here, I read DAT2 in. And this test is just telling you that they are exactly the same. Nothing was lost in this writing process. They are exactly, if you loaded up R and read this in, it's just like whatever you had in memory beforehand. So again, we're going to go out to the lab so you can do some reading and writing of RDS file. And I would pause here, but I'm going to move on. So there is a question many times. You close your R, it says, do you want to save .r data? Do you want to save your workspace? I will say if you're working in a project, that's probably an okay thing to do, but I generally don't rely on that. I don't rely on that because I don't know how that data was generated, and I pretty much want to be able to reproduce my entire analysis from raw data to final output using a set of scripts. Now, if I was working on something and I just had to quick save something, maybe I would do that, but most likely I would just save the script that has all the steps of reading in something on disk and getting something to the format I need it to be, rather than saving the workspace. So that being said, if you do want to save multiple things, you can save them into what RDAs, or R data objects, that are a little bit different than RDS files. So RDA or R data is generally the way they are written on disk. That's the extension that's usually used. So here, for example, X is equal to 5 and YTS is equal to that youth tobacco survey. So just note also, just one quick aside, you can also put semicolons at the ends of your functions. It's not a big deal. If you come from a different language or that makes sense, you can do that. Now, the opposite is, so we said read_RDS, write_RDS before. Here's a little bit different. This is save. This is a base R function. It's not a readr function. But what the arguments you give to save are all these different types of objects, and then you give it the file. You have to say file equals. You can't just put guess that the third thing is the file, because what it does is it guesses everything in here as part of this output you want to save, and then you tell it what file it is. Now, this is an RDA file, but the big difference is, what I'm showing you here, is that you say load. Now, ls is a simple command that lists anything in your workspace. So if you look in that environment pane, it'll show you pretty much the exact same things here. ls is a listing of those objects. It doesn't show you the structure or any of the additional fun features that the environment pane does, but it says these are the things that are loaded into memory. And what I'm saying is DAT2, some other extraneous things, X and YTS are in there, and I'm saying remove. So the RM function removes them from memory. It clears that memory out. Those things are gone. They're deleted. So I could have either done remove X in here, or I can actually pass in a character vector of the things I want to remove. So in this case, that argument is called list. So I say remove list equals X and YTS. Remove them from memory, and now when I list out the things in memory again, those two things are gone. So that actually did remove them. Now, when I say Z equals load, when I assign Z to be the output, It doesn't do what you think it does in many cases. So I would naturally think in every way we've done things, when I assign something to the output, that should have all these things kind of contained in it. That is not what happened. If we list out things, we have everything from before. Z is now created, but X and YTS are now generated in there. And that's, now if we look at Z though, Z is just the character vector of the names of the objects loaded, not the objects themselves. So when you say load, if you didn't put Z in there, excuse me, X or YTS will get loaded into memory. And these variable names have to do with how you save them. So one nice thing about RDS files, it says like, hey, I don't care what I saved it for. I call it DAT4, DAT98, DAT2, whatever. It doesn't matter because when you read it in, you can assign it to a new name. Save and load, on the other hand, it matters what you saved it as. So if you said, I loaded this thing, it's like, oh, what did I call that thing? Was it X? Was it Y? Was it Z? Was it YTS? I don't know. You have to remember those things, but you can assign the output to something. I generally, though, use read and write RDS files. Even when I want to save a whole set of objects, I use this thing called a list sometimes. But save and load can be useful, especially when you're starting out. If you want to save everything or a whole set of things like, you know, your data set, your model, a table of results, you know, things like that, together in one object, an RDA can do that for you. So that is the ins and outs of data input. So we will talk about how to generate tables and things like that, and then write them as CSV or actually output them in an RMD file that looks a little bit better. But more or less, what we'll be doing throughout the course is, let's say, taking in data, ingesting it, manipulating it, changing it, cleaning it up, putting it in a model, maybe making a model output. We can turn that into a regular data set, a regular data frame, and we can save that as an RDS. We can save that as a CSV. There are ways to write it to Excel, but generally I shy away from those just because sometimes those packages can be a little bit finicky, and I like to do the formatting on my own in Excel to polish it, or I'll do the formatting in a system like LaTeX or in R Markdown itself. So we'll talk about that in another lecture, but this was data input output. Thank you.